Okay, so in this video we are going to look at constructing a 95% confidence interval for a population proportion. So we have a new formula here, like earlier, our margin of error. Just a slightly different formula because it's a population proportion now and not a mean. Is your root of p times 1 minus p all over n. Okay, so for population proportion, the way the question will be set up is that we'll be given a kind of master figure. So like in this question here, it's 1200, and then they tell us only 324. So we have a subgroup of the population. So that's your population proportion. And just the second thing to note then is that we usually aren't given p. So within our formula, where we see this p value here and here, we replace that with p hat, and that lets us calculate the true proportion that will lie within 95% of our two values. Okay, so we'll have a look at this question. So they tell us 1200 voters, 324, and then here's our question itself. Okay, so we have to calculate p hat first. It'll be 324 over 1200. You can test this in your calculator, and if it tidies up to a neat enough decimal, you can work with that. Otherwise, we'll leave it in fraction form. So here we get 0.27. That's fine. And then we have our n value is always the original, so 1200. And then our formula will be our p hat plus or minus 1.96 times your root of p times 1 minus p over n. Now in this one we don't know the p value or proportion, so we substitute that for p hat. Okay, so we have 0.27 minus 1.96 times the root of 0.27, 1 minus 0.27 all over 1200 will be less than or equal to p, our true proportion, and then same formula, we just swap the minus for a plus, and the root of 0.27 times 1 minus 0.27 all over 1200, and into our calculator. Now you don't need this step in between where you tidy it up, but we'll put it in just for this example. So 0.27 times 1 minus 0.27 all over 1200. So we get 0.0251193.101. And then the second time we're adding it. So your decimal will never change between these two sides. Okay, so we have 0.27, our next line minus 0.0251193.7101. We'll give back 0.24488069 less than or equal to p. And then the second time you're going to add it. We get 0.2951193.71. Okay, so there's our true proportion, and that'll be as a decimal, so to convert it to a percentage then, if need be. The question doesn't clarify, but if needed then it'd be, and we'd round as well. So this one would be 24.45, and then here we'd have 29.51%. So just at the end, we can tidy it up to our range. We get 0. We'll go for maybe 2 decimals here, so 0.2449, 0.2951, or then rounded would be, and in decimal form, would be 24.49%, and then 29.51%. So again, in state exams, the question will clarify what form your answer should be in, and the context of the question maybe might be a little bit more clear in that aspect. But that's your approach there for your confidence interval. So in the sample that they took, it was 27% of voters believed that the government officials should be raised, and then for our whole sample of 1,200 voters, we're able to figure out that 95% of them will agree, and between the ranges of that between 24.49 and 29.51% of them will agree that the salaries should be raised. Okay, and that's us done for a 95% confidence interval for population proportion.